morning, respected dignitaries, faculty members, and dear participants. On behalf of Jcet College of Engineering and Technology, I warmly welcome you all to the fourth day of Faculty Development Program titled From Concept to Manuscript, Mastering the Art of Research Paper Writing, organized by the Department of Electronics and Communication Engineering. I take this opportunity to warmly welcome our chief guest, Mr. M. Malayappan, ME, Director, Pantech Group of Company, and Mr. Devanandan, Marketing Manager. Sir, your presence here today not only adds grace to this occasion, but also motivates us to pursue academic excellence and research with renewed energy. We are deeply honored to welcome our principal, Professor Dr. S. Satish, Jcet College of Engineering, for gracing the occasion. We are also pleased to welcome all our respected faculty members and the participants who have joined us from various institutions. On behalf of our institution and everyone present here, I extend a warm and respectful welcome to all of you. Let's do the honoring for the day. I would like to invite our principal to honor our resource person, Mr. M. Malayappan, with golden garment and memento. Thank you, sir, for doing the honoring. Now it's time to let us know about our chief guest. I would like to invite Mrs. Tennarasi, CSE Department, to give the chief guest introduction.
Good morning. Good morning, one and all present here. It is our honor to welcome Mr. M. Malayappan, Director Pantech Group of Companies, an accomplished engineering innovator and educationist as today's chief guest, with over 2 decades of rich experience in power electronics, electric vehicles, renewable energy systems, and embedded controller design. Mr. Malayappan stands as a pillar in the field of electrical and electronics engineering. He earned his bachelor's degree in electrical and electronics engineering from the Government College of Engineering, Barkur in 2002, followed by a master's degree in power electronics and drives from the prestigious College of Engineering, Gindi, Anna University in 2004. Mr. Malayappan's contributions to research and development are notable. He co-authored on IEEE paper titled Transient Analysis of Induction Motor Using Finite Element Analysis, presented at the ICON 2004 13th Annual Conference of the IEEE Industrial Electronics Society. His professional journey is marked by remarkable achievements, including designing a 350 kg four-wheeler electric vehicle prototype in 2022, conducting 150 webinars and workshops, reaching over 10,000 participants globally, developing a 1 kilowatt solar and wind hybrid power generation system in 2020, leading a TI-backed MATLAB integrated power electronic project in 2018, installing 5 kilowatts and 6 kilowatt solar systems in reputed institutions like Jcet and CIT Coimbatore, organizing international workshops in collaborations with NIT Karnataka and Anna University, expertise in vector control, closed-loop motor control, and FPGA-based multi-level inverter design. As Director of Pantech e-Learning, he has been a driving force behind innovation and technical education, mentoring thousands of students and professionals in cutting-edge areas like electric vehicle design, MATLAB Simulink, and power converter systems. We are truly privileged to have Mr. Malayappan with us today Please join me in extending a warm welcome to our esteemed chief guest, Mr. Malayappan.
Thank you, ma'am, for the brief introduction. Now I'll hand over the session to our chief guest. Let's all listen to his.
Yes, very good morning, everyone here. I thank you for this providing me as a wonderful opportunity. I think I would like to invite this session everyone here, and uh, yeah. Let me introduce myself, Malayapan. You can get a support from Pantech in the following area called. Is it audible? Is it audible? Yeah. So advanced power electronics and drives, electric vehicle, autonomous vehicle, and IoT relevant, related any research paper, you can get a support to make as a proof of concept, to make as a product, to make to the, to reach the market, whatever the topic, we are ready to help you on this domain. And about the Pantech, next slide. About the Pantech, Pantech is basically educational equipments manufacturing company. From Pantech, you can get laboratory equipments for ECE, EEE, computer science, AIDS, and robotics relevant. You can get it. In addition to that, we also help the people to get high-end technology training. And our vision is to help 10 million students to learn the technology in easy way. So in the easy way. So through this vision, we are conducting lot of free training programs in our online platforms like Zoom or YouTube or any specialized program. And also we enable you to associate with IETE forum or IEEE forum or NATK forum. We have strongly associated with the 4 government of Tamil Nadu, government of Karnataka, government of AP. Through this forum, we will connect you, and since you all are belongs to academicians, so we help to get a direct interaction with the industry, as well as that networks, right? So through Pantech, you can organize such kind of FDPs. You can get value-added courses and hands-on training on any latest technologies, right? We are very happy to associate on this way. And today I just scheduled how to how to develop or how to work with the future mobility. And today the topic is about future mobility. So here I prepared the content to discuss, to get a deep dive into this particular domain. So which means that, so after this session, if you put your just 2 hours time to this presentation, you can able to develop your own vehicle, and you can able to do research and how to use any AI tools to build your own paper. Not only the paper, any research proposals. See now that AICTE RPS program also happening. So after this event, if you put your time to attend this presentation, after this event, after this presentation, you can build your own proposal to submit this recent AICTE RPS program, RPS scheme, right? So in this way, I organize the content. So let us go in detail about the content and how and what, how we can develop our own vehicle. Since we all are from the engineering background, so the mobility is not only for the particularly about that electric vehicle or electrical department or mechanical department. Now the mobility is common for everyone, right? So the basic platform will be the like electrical or mechanical, but the usage and then adding a top of features to the mobility, that is a common for everyone. Right. So in this manner we can approach the content, and I hope I will deliver, I will share all the content to you. So you will enjoy the session. If you have any queries, you please share your share your questions in the chat box. I am ready to help you in all possible ways. Right. Yeah. See now let us talk about future mobility. So what do you mean by mobility? What way we have to approach this domain, since the mobility is, the transportation industry is running across the world for past 200 years. Now, this has not happened in the, yesterday or day before yesterday, right? So the entire transportation market, it's like a $1 billion market. So each and every day the new technologies are hitting the market. So here the technologies are always help the people to enrich the sophistications. Right. So in this way we should approach this content, and see here. So what do you mean by mobility? So as of now we have the conventional vehicle called IC engine powered vehicle, right? So in this of course we know that IC engines are the fossil fuels are limited one. So we are in the position to identify alternate sources. So how we can identify the alternate sources? So we have a sustainable, we should create a sustainable world. So in this way we should depend only that renewable energy systems. So here if you talk about renewable energy systems, that major 95% of the content will towards that electricity, production of electricity, conversion of electricity, and then usage of the electricity. So how we can convert, how we can produce, how we can utilize that energy to make active active work to be done, right? So that's why we are in the position to adopt new technology for the mobility, transportation industry. So now due to the advancement happened in the solid state, like material sciences, right? So due to that we got a super duper technology on the material sciences, like high-end solid state devices. So due to that only we are getting the microcontroller, we are getting the right? So whenever the technology happens in this domain, of course we are getting fast super faster processor we are getting. So through this platform we are trying to build a additional features to the system. So here how we are getting this features? See here hybrid, IC engine has been converted as a hybrid engine, because for small assistance, we have introduced some electrical power to the system. So which means that instead of depending 100% the fossil fuel, we are just reduced 100 to 80%. So 20% we are saving, we are trying to save the power, right? So similar way, the hybrid, IC engine adapted the electricity for these functions like how to start and ideal state and some power assistance whenever it requires more power. So for these domains, for these scenarios, that electricity has been utilized in the IC engine. But now the scenario is entirely different. So we have completely adapted that electricity to the transportation market. So how we are utilized and why we should adapt everything, right? So of course, EV has 100%, 200% advantages and disadvantages, whereas there are some limitations. Let us check one by one. So what are it? How to how to overcome those limitations? And second thing, wherever the problems, so it's not a problem, it's an opportunity for others, right? So if there is a limitations, since we all are the engineering background, so we should see that limitation as a opportunity to do the research, right? So now, why we should adapt? So of course, we know that we have very limited, next one. We have very limited power sources, so we should adopt the EV, right? That is electricity. And the second thing, with the IC engine, there are lot of carbon emissions. So the entire world is directed to reduce the carbon emission, right? So this is what we are trying to reduce the power, convert the IC engine to electricity. Of course, there are advantages, there are some limitations also. So if you talk about cost wise, the cost analysis for the EV, in the sense, initially it looks like a higher cost, but once the entire market try to adopt the EV, then of course, the cost will get reduced. But after the investment time, the maintenance period is 1/3 of the IC engine cost. See now, if you take the scenario, like if you have any IC engine, the IC engine every 6 months once you should service the vehicle, right? Per service cost is around 10 to 12,000 rupees. Whereas if you compare with the EV, that is 1/3 of this cost, like around 4 to 5,000 rupees will be the service maintenance cost, except battery. So here the battery is the biggest culprit in our investment. In the entire EV cost, around 60 to 70% cost going to the battery systems. So rest is very less. So that's why again there are few more opportunities are available to do research and how to adopt the technology, how to reduce the cost. All these things I have scheduled. You please just engage the entire presentation. So definitely I assure that you will get something from this slide, right? And second thing, the environmental. Of course, with the EV, we are in the EV vehicle part, we are 100% we are reducing the carbon emission. Whereas in the energy production side, we are creating lot of noises comparatively. That is the double the time of in the fossil fuels basis comparatively. But there are some solutions like hydrogen powered solutions. If we try to adopt hydrogen powered solutions with the mobility, then definitely we can claim that we are reducing the carbon emission comparatively that IC engine powers. And third one is that energy efficiency. See here, if you talk about efficiency, the electrical machines will work up to 95% efficiency, whereas you cannot get the similar scenario with IC engines, right? So in that aspect, that EV will produce the higher efficiency. And the final one is that limitations. Do you have any idea about what are all the limitations with the current EV vehicles, electric vehicles? Do you have any idea? So now, I mean, the very first issue is that range. We cannot, I mean, what? We cannot drive blindly with the EV for 500 kilometers per day or per charge. There are few, I mean, there are, huge limitations are available. We cannot safely travel 500 kilometers with the EV on single charge. Of course, we should invest our 1 to 2 hours time in between. Then only you can get again 80% charge. But safely, suppose if you are getting 100 kilometer travel per day, in that scenario, the EV is the 100% right choice. Right? If you take a vehicle from house to office and then office to home, and the total kilometer is about 100 kilometer, 150 kilometer, 100% the EV will suit to you. Otherwise, the EV will not suit to you. For that, again, you have to reinvest the battery, or else you have to go for the higher battery capacity. That is the biggest disadvantages. And of course, we don't have much infrastructure. That is the EV charging infrastructure we don't have. There are, it needs lot of investment on the infrastructure side. And second one is that temperature. In the battery side and in the cabin side, we don't have a proper system to manage or maintain the temperature, because the EV is always a dynamic load, and our terrain is also not a uniform terrain, right? So in that case, what things will happen? How the things will happen? Like, due to the temperature variations, due to the terrain variations, the temperature, the motor will draw more current from the battery. So due to this behavior, you know that battery will behave abnormally, and the deliverable current by the battery is directly proportional to the temperature changes. So that's why the people are telling that is more important as a human health. So day by day, we should take care about the battery in the aging aspects, in the temperature changes aspects, right? So these are all the critical parameters. So you have a lot of chances to do lot of research. Not only the research, you can get, if you have a solutions, you don't need to do anything. Lot of government schemes are available to get a grant. Suppose simply if you have a proper solution to reduce the temperature changes in the battery, then you can get initial grantees like 3 lakh rupees you can get immediately from the government of Tamil Nadu. And once if you identify the POC, proof of concept for your idea, then you can get a 7 lakh rupees, additional 7 lakh rupees to implement the same idea. Same way, if you implemented the idea, and again if you want to take to the market, then the government will give you again 15 lakh rupees. So that parallelly, see, actually, you know that in the Europe or US, who is owning the company? Earlier days, many college professors only started the company, right? So now the same scenario is going to happen in Indian market also. So now that's why you are getting lot of incubation centers. The many schemes are available to start an incubation center. So you can easily associate with your students, and you can start the company, and you can do the lot of research. So for that, here the point is that you no need to wait for the fund. If you have an idea, definitely you may get a clear path to reach the product level, to the market. That kind of ecosystems are available in Tamil Nadu. Not only Tamil Nadu, all the states are providing such kind of scenarios. If you need any help to start a company, to take a product to the market, to convert an idea to the product, you just reach me. I will help you to convert product, to reach the market, everything I will help you, right? Yeah. So these are all the advantages and the disadvantages of the EV. And Yeah. So what is EV and what are all the components, major components? How we can simply understand the concept, right? So now, if you take electric vehicle components, so let us classify into three modes. Let us classify into three modes. The first one is that vehicle structure. Of course, we know that vehicle structures are the first components, bundle of vehicle. So in this one, wheel, vehicle body, and then gear mechanism. This is the basic vehicle structure. So I mean, to kickstart any research, you should start from this point. Of course, that thing is that how to how to configure the components, and how to choose the components, and how to design the components. All those things you have to start from this point. And the window and glass and light, music system and infotainments, everything is that other classifications. But for making the POC, this is the first two model is NF to kickstart the project. Yeah. So now, so how we can understand the power flow of the EV? You know that through the charging station, we are getting the power to the battery through the OBC model, like onboard charger model. And once the battery get powered, now the battery will give power to the vehicle through the inverter and then motor, right? So here the motor can be anything and the converter may be anything, like based on the motor we have to choose the converter, right? So this is the major components of the EV. So now we should know what all the motors are available in the market, how to choose the motor, all those stuff we should know. Do you have any idea about latest advanced special electrical machines? You know that induction machine DC motor is the conventional engines. So now the BLDC, PMSM and SRM, these are all the advanced machines to power up the EV. So that there we can get a more torque and lesser size and high speed, all those stuff we can get it with the higher advanced electrical machines. Comparatively, that DC machines and induction machine, comparatively we can get a higher power from the advanced special machines. So now, how the power flow is happening? So the power flow is nothing but like through the you know that a driver will generate an accelerator and decelerator, right? So how we are driving the car? So we are just, whenever we want to move, we should apply an accelerator. Whenever we want to stop the vehicle, we should apply a brake, right? So here the accelerator, nothing but the accelerator, that is called a PWM signal. Similar way trigger signal for the brake, right? So the two signal has been converted as a PWM and fed into the microcontroller, and the microcontroller will generate a PWM relevant to this input, and the PWM will fed into the motor controller, right? The motor controller will control the motor at end of the series. Finally, we are getting the movement in the vehicle, right? This is the way we should understand the power, controlling mechanism of the EV. Now, so how to understand the, first of all, we should know vehicle basics, right? What is vehicle, how to understand the vehicle, all those stuff we may require. Yeah. So now let us try to, just imagine that one ideal car is parking on the flat terrain. You know, can you just move the vehicle without any power? Do you have any idea? Can we move the car without any power, external power? No, it is not possible, because due to its own weight, that the gravitational force will act on the body, right? So whenever the gravitational force reduces due to the various conditions like a flat, instead of flat terrain, if there is a downslope or upslope, the gravitational force may vary, right? So in that condition, the vehicle will automatically will get moved. Till that time, it will not move, right? So now we should understand the basic physics. So what are all the forces may act on the body? You know that the forces act on the body called the friction forces. So now if you want to move the vehicle from standstill position to movable, you should overcome the friction force. So here how to overcome the friction force? Just put one external motor. That motor will overcome the friction force, right? So by that situation, by that moment, the vehicle will try to move from one position to another position with a particular velocity. For that, you should control the motor on particular velocity. This is the simple mechanism to understand this next, right? Yeah, next. So now if you want to move the vehicle in the particular velocity, so like a 20 km per hour or 40 km per hour, 100 km per hour. So here whenever the velocity comes into the picture, if you take any object, there will be a aerodynamic force may act on a body. Until unless if you are not trying to move the object on particular velocity, it won't act. If you move the object on particular velocity, then the aerodynamic force will act on the body, right? So how we can overcome? Of course, each and every object will have its own area. On that area, the air will act opposite into that object direction, right? So now we should improve the design to reduce the air cut section area. That is called what? Aerodynamic design, right? So that's why you just take any high speed vehicles will be like aerodynamic design will be implemented on the particular vehicle. Then only we can reduce the aerodynamic power losses. So how to calculate the total power requirement to move the vehicle from one position to another position? So what you have to do? So you have to calculate total active tractive forces and multiplied by the velocity of the vehicle. Then you may get a total power, how much power you should adopt into the vehicle, right? This is a simple calculations. Now I will take you one more calculations, like what are all the detailed forces act on the body. Very first one is that rolling resistance force. That rolling resistance force nothing but the vehicle having the tires. The tire is going to rub the road, right? So due to this behavior on the vehicle, that opposite friction will create. That will let you. I will tell you in forthcoming slides how to calculate all the forces. Same way like a hill climbing force. Of course, we know that our terrain is not a uniform terrain. So terrain always keep change, right? So whenever the terrain is downslope, then we no need to put more power. Whenever the terrain is in upslope, upgradient, then we need more power to climb this area, climb that particular area, right? That we have to calculate. And finally, that acceleration force, like it will be a linear acceleration and there is and the angular acceleration. So all these things needs to be calculated, and if you taken care about all the functions, then you can reach the total power of the vehicle. Now see here, what is that rolling resistance? See, the rolling resistance is the frictional phenomena that we can be calculated with the help of this formula like a mu rr m into g. So here mu rr and m is the constant. Here we are going to use only the m, like a mu rr and g is the constant, m is the total weight of the vehicle. So if you know this parameter, we can easily calculate the mu rr. And second thing is that aerodynamic drag force. So here the aerodynamic drag force nothing but when you try to move the object on particular velocity, due to its vehicle dimensions, high pressure and then low pressure area will create on the object. So how can we calculate that one? Like rho of rho CD A V square. So here rho CD and rho and CD is the constant, like a frontal area, rho is the air density. You know that air density is like a 1.25. I will tell you I will give you the sample rate. Yeah. So rho is the air density, and A is the frontal area, like width and height of the object, and CD is the drag coefficient that we can reach through the aerodynamic design. And rest two parameters like frontal area and then velocity is the data which we have to choose or design. And the some typical values for the road and for the selection of drag coefficient. Yeah, just move. Yeah, one more. Next. Yes. See here. There are different type of vehicles. Whenever the vehicle have the flat, flat cut section, it will have a huge drag coefficient, because that air cut section is high. Comparatively, that just take the analysis the 4 images. That airfoil size is very less drag comparatively that the truck flat plate, right. So similar way you can select this sample values based on the type of the vehicle. And now the hill climbing area. See the hill climbing force, you know that due to the terrain deviations, we are in the position to take this into this consideration, like mg into sin theta. So here m is again the weight, g is the constant, and here the theta. Generally in the infrastructure domain, the people will keep maximum 20% for the construction of the bridges or domestic usages. 20%, 20 degree is the deviation, maximum 20 degree. Whereas for the off-road side, it may go up to 45 degree. For more than 45 degree, your vehicle will not get any equilibrium. So you cannot climb that position. So for that, you have to take alternate directions. Next. Yeah. And so if you take a total, power required, first we should consider all the opposite forces: rolling resistance, aerodynamic drag force, hill climbing force, and then linear acceleration and then angular acceleration. So this is the simple formula to apply on the vehicle to get a first POC level output. First POC level output. So now, here we have discussed the rolling resistance, aerodynamic, and then hill climbing. What about the linear acceleration and then angular acceleration? The motor will be placed somewhere in the vehicle, but the tire only going to give you the velocity, movement to the vehicle, right. So the end of the moment, the tire going to rub on the road. Due to this action only, we are getting the movement in the vehicle, right. So here you just imagine that the force production is at the motor shaft, and the force transfer, we have to transfer the produced force to the wheel, right. So there will be a power transfer port will be placed. So how can we overcome, how can we calculate those informations, like gear mechanisms, right. So to calculate that one, linear and angular acceleration forces formula, use that formula. And so next one. So now let us take a simple calculations. Yeah, just take a simple calculation, take a snapshot, and try to use your own vehicle. Like weight of the vehicle is 1000 kg, and width of the vehicle is 1 meter. Similar way, 1.5 meters height, and the rolling resistance, air density, drag coefficient, gravitational force constant. These are all the constant we have selected. So of course we have chosen that we are going to develop a two-wheeler, half car model or two-wheeler model, right? For this two-wheeler, I have selected this area, these parameters, and I have opted that 40 kilometer is the vehicle speed, right? So first one is that for simple understanding purpose, let us omit linear and then hill climbing area, right? Opposite forces. Let us consider rolling resistance and then aerodynamic drag force alone. But for actual cases, you have to consider all the things. If you want that calculation, you please connect me after this presentation. I will help you for entire calculations. For simple understanding purpose, just to take these two calculations. First point is that just convert velocity from kilometer per hour to meter per second, right? Now we have chosen 40 kilometer. So just to convert 40 kilometer per hour into the meter per second, right? That is 11.11 meter per second. That is a velocity. And take a calculation for the frontal area. Just to multiply width and height, you may get a frontal area, right? So in the rolling resistance, aerodynamic drag force, you know that all the parameters now you have. Frontal area you have, total weight you have, and velocity you have, and constants you have chosen. So now can you make a calculation to calculate for the total motor power requirement? Is it so or not? Right? So can we, simply we can do our own calculations, right? So can you, I request you, the participants, just repeat the calculation for different velocity, different size, different weight, and do this calculation, post the calculations into your LinkedIn post. Today I learned something and I reproduced the content and I designed my own vehicle. So through this one, what we are trying to achieve that we have selected a motor of 2.5 kilowatt for this specifications, for this requirement. Alright. So now we know how much power is required to apply on the motor, apply on the vehicle. Is it clear? Do you have any questions? Yes. Technology, see here nothing but EV. Yeah, in the EV, major issues are temperature changes, and then efficiency increase, limited efficiency. Comparatively, IC engine is EV is the better efficiency, but still we need 100% efficiency. The two area you can put your lot of research, and these are all the basic dynamics. If we want to verify this dynamics, we should know any one simulation tools. The simulation tool nothing but like any one MATLAB or ANSYS or ProE or nowadays many tools are available. Altair and Siemens, so many tools are available. But predominantly MATLAB is used by many industries. Wherever you go, MATLAB is the only tool people are following, because MATLAB has a what? MATLAB has a interdisciplinary solver. Like you can, you can take a real-time physical data into the simulation side. The simulation will generate exact results as per the real-time data. That's why the people are trusting that MATLAB. So if you know, if you are working with MATLAB, then you can easily crack into this domain. right? Yeah. So through these calculations, we can achieve that how much power I should select. Now we have calculated 2.5 kilowatt is the total motor power. So how to choose the motor? There are multiple motors are available. BLDC, PMSM and SRM and interior permanent magnet synchronous motor. Many motors are available. So you know the type of EV, 2-wheeler, 3-wheeler, 4-wheeler, right? For the 2-wheeler you can go with the BLDC motor. Whereas 3-wheeler and then 4-wheeler above, whenever you are requiring, whenever you are you need to keep more than 3 kilowatt power, you should opt PMSM or SRM motors. More than 3 kilowatt, less than 3 kilowatt you can go with the BLDC motor. DC motor and the induction motor will not suit for this applications. Sometimes induction motor also it's suitable, but now lot of technologies are available. We can get a better efficiency than the other motors, right? So now we have opted that motor power. So how to choose the battery power, right? We have selected the motor, but how to choose the battery power? You know from the calculations. So let us consider the 100 km per hour. So the motor power demand is 8.1 kilowatt. So which means that your vehicle, if you want to run the vehicle at 100 km, you have to produce 8.1 kilowatt motor power at the motor shaft. In that case, what is the motor power? 20% higher than the actual requirement, right? So you need 8, you have to produce 8 kilowatt. So 10 kilowatt motor can produce 8 kilowatt power, right? Simple simple understanding. And step 1, try to get a maximum full load current. Assume that 10 kilowatt you have chosen and 72 is the terminal power, terminal voltage or system voltage. So here we have to choose the voltage at on what range, like for 24, 48, 60, 72, 100, 300. These are the system voltages. So the system voltages is directly proportional to the what? Is directly proportional to the motor cost. At the same time, inversely proportional to the size of the motor. And then conductor, current carrying conductor is inversely proportional. So now you know that if you keep 12 voltage, the full load current will be more than 300 ampere. So now we have a 139 ampere is the full load current, right? So here you have a choices how much current you have to operate in your circuit. I have selected 72. When I select a 72, then I am getting 139 is the full load current. So here, which means that my vehicle is fully loaded and running at a rated condition, rated speed like 40 km per hour, 100 km per hour. Second step, how long you are going to operate the vehicle. So let us assume that I am going to run the vehicle for 1 hour, or else I am going to run the vehicle for 800 km within 1 hour, right? In that case, I am going to dissipate the power from the source like a 10 kilowatt hour, right? So 10 kilowatt hour I am going to dissipate into the system. So in that case, I should have a higher power in the bank, like a battery bank. Then only I can take and dissipate the 10 kilowatt hour. So just keep 20% higher than the actual demand. So here 12 kilowatt hour is the total battery capacity, 12 kilowatt hour. So from this 12 kilowatt hour, we can dissipate 10 kilowatt hour, right? So we have chosen 72 is the system voltage and 166 is the full load ampere current. So just multiply, you may get the battery rating is 72 voltage and then 166 ampere R, right. So by this way we can calculate the battery power also, right. These are all very basic informations. So just want to take get into this future mobility, you should know how to choose the motor, how to choose the battery. Suppose if you are going to purchase any EV, you should know how to validate your vehicle ratings. So the people will use 50 kilowatt hour battery or 100 kilowatt hour battery, that's why I am charging this much. In that case you should know how to validate that value, right. Next. Yeah, next. So yeah, so now by simple understanding, if you run the vehicle at rated conditions, you can reach the 100 kilometer in 1 hour without any other hindrances, and after 1 hour you will have a 20% remaining battery, subjected to terrain conditions, driving scenarios, temperature variations and other climatic conditions. So these are all the ideal conditions. These are all the ideal conditions. I hope you got the point. Any more doubt? If you have any doubt, please let me know, I will give you the answers. If you have any questions, just let me know, I will try to give you the answers. Yeah, okay, let us answer the questions. Yeah, how do you see solid state batteries impacting the EV market compared to current lithium ion technologies? You know that lithium ion batteries are highly subjected for the vibrations, whereas if you have a solid state battery, we can overcome the that issues. So in that case, considerably the temperature changes can be reduced. Definitely it will impact on the future market. And what are the major challenges in developing EV charging infrastructure, especially in the rural or underdeveloped regions? See here, EV charging infrastructure is the biggest investment area. Blindly we cannot put a EV charging station wherever we have a space, empty space, because there are few more technology changes is upcoming, it's lined up. As you mentioned earlier, as I mentioned earlier, like fuel cell is going to hit our market. Once if the fuel cell technology is reached in our hand, we no need this much bulky size of batteries in the vehicle. Now we have around 40 to 70 kilowatt batteries available in the electric vehicle. If you have a fuel cell into the system, we may not require that much battery capacity. It like a 2 to 3 kilowatt or 5 kilowatt battery capacity is enough, right. So in that situation, keeping a high fast infra DC charger is, it's waste of time, right. That is the technology lineup. But whereas answer for this question is that the power availability, of course we can keep we can keep EV charger into the we can install the charger into the charging station, but the sources to the charger is biggest challenge again. So now one more business is happening, like micro renewable systems or hybrid systems, like a small wind power and then small solar power, and combined but that is very limited. The range we cannot extend, and that is the biggest challenge. Suppose if you have a limited less size, small size wind turbine, then you may get a better options. And the second scenario is the power quality. The input power quality will be highly disturbed whenever you try to keep larger charging stations. That is the second challenges. For that one, we have to design a high power factor correction circuits, or else like a more large number of filters you may require. And third one, what are the environmental concerns related to the EV battery protections and disposal? How they can be mitigated? See here, environmental conditions. The protection of battery also we can somehow manage, but whereas the disposal of the battery is the biggest challenge. What extraction of the chemical from the battery, removal of the battery, and then deposit to the battery, deposit in the earth side, that is the biggest challenge. So that really it's a more chemical people are working, chemical engineering are working. But as a engineering, electrical or electronics engineering side, we can increase the life cycle of the battery. See, in single cell, so if you take this same battery rating, you may require around 1,000 cells are required. After warranty period, out of 1,000 cells, 30% cells may get damaged. So like 300 cells may get damage. So now the point is that instead of throwing away 1,000 cells, just throw away only 300 cells. Replace the 300 cells with a new one. Then again you can recondition the battery. Right? You can increase the extra life. You can get extra life to the battery. By this way we can provide the solutions. And the next one. Yeah, what skills and knowledge should researcher focus on to the contribute meaningful to the future of EV mobility? See here, suppose if you belongs to electronics engineering, you can work more about that OpenCV based image processing solutions. So that near future we are going to adopt lot of we may require lot of camera based solutions to enrich the EV, right? So and try to work with the Jcet, any GPU based process. That will help you a lot. Yes. So here, how to fill the gap between the EV industry and then academia. You know that in the industry people, we look whether the people are ready to learn. The first thing, that is a basic criteria. And second thing, at least the people have used or heard the name of the tools which we are using in the industry. Like what are the toolboxes, what are the standards. We should focus on the standards now. Simply just, see, let us take this scenario. Now we are trying to design one 5-volt power supply. You know, for this task, simply just take a 7805 regulator, you can put on a bridge rectifier and then on filter capacity, the power supplies will be get ready. But are we discussing about the designed power supply will suit for the different conditions and different load conditions, different climatic conditions, and how much will be the withstanding conditions, what will be the regulations. So these are all the standards. Of course, in the academic side, we should talk more about the regulations. If we started to talk about, then definitely I assure that the gap will get reduced. So we are not considering, I mean, we all are putting our efforts to learn the basic things. So end of the day, see, of course, if you are going to purchase any mobile, you are always keep on checking that how much is the speed, how much is the temperature withstanding capacity, what is the form factor, and what is the charging capacity, all those factors which we are following on regular day-to-day basis. The same way we should adapt into the skilling portions. Alright, so by this method we can improve that things. Yeah, if you have any more questions, you please ask me, let me give you the solutions. Yeah. Just yeah, next one. Yeah. So what are all the emerging technologies? What are all the emerging trends and technologies? You know that we should now we are in that EV era, but very soon we are going to have a autonomous vehicle in our hand, right? And so once if you talk about autonomous vehicle, so there are multiple options like connected vehicles or software defined vehicles. Once if you achieve that connected vehicles, then you may get easily that shared mobility. Like now it is happening in the Europe and Western countries and then US markets, that shared vehicles. See now I reach the campus by a car. So till my return, the vehicle will be in the ideal conditions, right? So now we are using that with a man, with the driver assistance. We are, what we are sharing our vehicle. But very near future, that scenario may not require. So similar way that shared mobility models, and similar way like mass like mobile as a service. We can share our vehicle for other services also. These are all the area we have to concentrate. We are going to hit as a business model, we are going to reach, and alternative energy sources like hydrogens and then solar, like a small form factor based on that one, and then smart infrastructure with V2X communications. Nothing but we can share the power from vehicle to vehicle, from vehicle to any devices. So that will happen very soon. It will happen. For that, there are a lot of protocols involved, and similar way like digital twins and then simulation. Simulation in the mobility. You know that digital twin. The advantage of digital twin is that to get a better understanding, to get a better visibility. All right. So like next version of IoT, simply we can call it as a next version of IoT is the digital twin. Now the current IoT will give you the two-dimensional view, whereas the digital twin will give you three-dimensional view. You know that in the Pantech we are providing autonomous vehicle. So this kind of vehicle can run within the campus without any driver. So the POC vehicle is a single seater, whereas we are providing you 4 seaters. You can roam the vehicle without any driver, as that real-time car. So through this you can do lot of research. You can take a data sets. You can implement multiple algorithm, and you can share the algorithm to the global community, and you can take a test data, you can verify the test data, and this vehicle has a lidar module and then camera module and then radar modules. So through this we can take a lane detection, lane following, alternate path, object detection, object classifications, all the stuff you can take it. You can get as a data sets. We will give you the complete solutions of the autonomous systems. So this vehicle has been powered up with NVIDIA Orient board with 64 GB GPU and inbuilt GPS, inbuilt lidar, 4D lidar module, and then high-end cameras. 2 cameras are available, front as well as the rear, and side all the sides are powered up with ultrasonic sensors and then radar sensor for the blind space detections. This vehicle will give you automatic parking and then automatic unparking. One case study give you the results like on an average each and everyone are spending their half an hour to 40 minutes time to park the vehicle as well as that unpark the vehicle on daily basis. You know that 40 minutes is how much is the crucial time. So our solution is that we will reduce that 40 minutes time for individual basis, right? That is the entry level of the advantages in the autonomous vehicles. Yeah. So now, let us come to that one. So how to start the innovations? So where to start the innovations? So to work with the innovations, you may require like you should know what is the history of our earth, what is the history of the economic evolution. Just go to it. This is the nature of the earth, right? So there are different colors, green color and then orange color and then pink color. What is the major difference between these areas, these colors, these regions? The major difference is the temperature, right? So near the equator line 0, right? So these regions are highly fulfilled by the earth. Yeah, all the minerals, all the human being livings is essentially it's available. Whereas beyond this region, something will be available, something will not be available, right? So the point is that in the green zone, everything we have in our hand. Whereas the orange or pink zone, something will not be available for day-to-day survival basis. So here the demand is the father of the innovation, right? So today I need this one, so I have invented like this. This is the simple psychology happening in the globe. So first we should understand. First we should realize that yes, something is demandable. I should work towards that demandable. Right? Next, go to the. This is the economic history of the earth for past 2000 years. The China and India have the complete world control in the past eras, because everything they have in their hand, right? So after day by day conversions, we started to lose our control, because everything we have in our control, in our hand, we have not focused on the innovations. So from the history we know that demand is the innovation, right? Demand is the father of the innovation. So we have everything, so we don't have anything, we don't require anything. That's why we lost our innovations. So now again we are, I mean, that's why the China has started 20 years back itself. They have started and then they have reclaimed the innovations. Now, China is the biggest innovator in the world. Not US, not Western countries. China is the biggest innovator in the world for past, I mean, recent years. But still we are trying to reach that one. That's why the government of India has taken lot of initiatives for the innovatives. So in TN startup, in TN startup scheme, you may get a lot of seed funds. I already mentioned, right? 3 lakh, 7 lakh, 15 lakh upfront. You may get a cash. You can do the work. You can, you can involve, actively participate in the research. Next one. Yeah. So here the demand is the father of the innovation. So now try to, catch up with this line and then stick with the line and try to think. Definitely you will get results. Yeah, next one. Yeah. See here, now you are developing any idea or project or service, whatever you want to do. So this is the simple rule. If you got the result answer for all the rule, then your idea will get ready. Your idea will be the super duper idea. Yeah. Yeah. So see here, this is 5 simple questions. Your idea solve the problem. Here across the globe we are 800 crore people, right? So my idea trying to provide the solution for 800 crore people, or else 400 crore people, or else 100 crore people, or else 1 crore people, or else 50 lakh people, or 1 lakh people. So now you should identify the count of the people. For that one, you should imagine that. Second question, by using your idea, the user gets connect with other people or not? That is the second question. And the third one is that your idea makes life easier or not? And your idea enables the economic channel or the financial channel or not? And finally, if your idea feels the luxurious, like if I have a car, yes, I feel luxury. If I have a like a Apple phone or Apple laptop, then I feel luxury, right? So similar way. So take any one idea, try to get an answer for this idea for all the questions, then your idea will be valid, right? So I hope you got the point. Yeah. So now so what are all the challenges and then research opportunities in this future mobility, right? So in the technical, there are some technical challenges. So I will tell you what are the technical challenges where you can put your effort, right? Similar way that ethical and then legal challenges. So here the ethical and then legal challenges nothing but very near future we are going to try to adopt that SDV, like a software defined vehicle. There are lot of securities are required. We should obey the rule, either in the privacy rule or else in the road, like a traffic rules. See, if you go to the Google and search someone number, if you have a number, you should not call to the people unless their permission, right? So by taking a mobile from the war porn forum is a criminal case, criminal offense at this moment, whereas the 5 years back it is not a criminal offense. It's a privilege to take a number, but now it's a criminal offense. By keeping like anyone famous celebrity number in my phone, due to that behavior, due to that facility itself, I should not call the connect the people, right? So that is, this all comes under the ethic. So now, how we are providing solutions to manage all these issues? How our algorithm going to solve the problem for these issues, right? And then infrastructure limitations, and then climatic resilience. So these are all the challenges which you can target to work on this one. And similar way, I will give you how to use the AI tools to address particular problem, to take a particular problem, and how to validate the particular problem. So let us check one by one. So in the technical challenges, battery technology, there are multiple problems are there, right? Range, charging. So let us take the two case study, range and then charging, slow charging. Why the charger will be slow? In the sense to limit the temperature changes. That's why we are using the slow charger, but we need a fast charger, right? Similar way that autonomous driving, sensor fusion and then perception errors and other stuffs. Here and all you may get if you have a proper solutions for these problems, your paper will get ready, immediately it will get accepted, and you may get a grant for this, all this stuffs. And third one is the integrations. How our vehicle and then infrastructure get connected, and due to that connections, how we can take a decision. The vehicle should understand the object, the vehicle should identify the object, and vehicle should act towards the object, right? So these are all the integration part. And the third one is the reliability. So how far I can trust my vehicle, how far I can trust my solutions. Even though if I have a camera in my car, whether can I trust the camera for the particular distance measurement, whether the camera is providing accurate distance or not, what are all the fault redundancy check. So all those stuff comes in under this place, right? So of course you may require advanced simulations and then testing frameworks like hardware in loop based solutions, software in loop based solutions. In this area you can get a lot of solutions, lot of challenges. Yeah. So you can drive your students to participate hackathon while you select a problem statement for the hackathon in this domain, that will hit immediately. You can get the results immediately. Similar way for the ethical and then legal challenges. You know, while you develop a AI algorithm, you know that the similar algorithm will give a different results for different climatic conditions, for different objects, different colors, and different voice inputs. So whether it is properly understanding the voice inputs. So if you take audio input to the system, there are multiple multiple faults may occur by the simple input. By the simple input, if you just take this scenario, you know that now we are using AI agent in our mobile, right? So you just name the AI agent, hey Google, tell me the date and time of the on particular event or something. So here the point is that what is a name, what is a event name, what is a location, what is a geolocation, whether I should share or not, everything. Suppose if you are just sharing your mobile to the other one, so which means that your entire secret is going to handle that second person at that moment. In that situation, your AI agent should react or not. So all these comes under this segment. These are all the problem statements. So now, based on these keywords, how to select our problem statement or how our research topic, let us check one by one. Just go to it. Similar way like data piracy and cyber security also. So these are all the things you can do lot of research focus on that blockchain or blockchain for secure transactions. So blockchain is the biggest opportunity for you in the security aspect for the software defined vehicle. Next. Yes. So yeah. So in the infrastructure limitations, charging infra is the biggest one. Second thing is that standardization. The standardization nothing but that topic will start from the port charging port onwards. Charging port is it the single phase or three phase? Is it the PFC rectified or not? All those stuff it comes under this area. All right. And so yeah, I mean charging station is the biggest limitations in this one. If you have a smart solution for the small low cost charging chargers, then you can get a better solutions. Similar way like smart systems. The smart systems nothing but whether are we providing roads or the smart sensor enabled roads, smart sensors enabled gates, smart sensors enabled bridges. These are all the additional infrastructures for the to adopt that EV into our day-to-day life. All right. Next one. And so you know that here, if you talk about material, if you take a material sciences, that will enable you different vertical. Like the same, you know that someone has asked me, like solid state battery will enable us to reduce 30% temperature changes, also absorbs 30% vibrations in the vehicle, whereas it is not possible in the lithium ion battery, because the lithium ion will react for the vibrations, while it is while the battery put under that vibration, then battery aging will get directly affected, right? So so here we may get a lot of options work with material sciences, right? So on the different climatic conditions, different temperature conditions, all those stuffs. Yeah. So see here, I recommend you please work towards this area like a software defined vehicle and then hydrogen mobility, like we Pantech will help you to get new age eras, new age research laboratories like hydrogen powered laboratory, and then autonomous vehicle laboratory, and then digital twin laboratory. So we have a wide range of components and equipments will give you, and with that proposal you can get your grants also from the government. You can apply the grants, right? Yeah, next. Yeah. So now so far we learned what is the technology, what is the basics, right, and what are all the business opportunities. So now how to write a proposal and where to write a proposal. Of course you are participating, you are engaging the similar content. I am just adding value, few more points how and what we are following in our laboratory, right? So next one. See here, first one is that, yeah. So there are multiple AI tools are available, but you have to select your topic. You should not allow AI to select a topic. You have to choose the topic, right? And second thing, blindly don't trust the AI tools. Always keep second check. That is our And we are using these tools like ChatGPT. We have enterprise editions, and Elicit, and then Site.ai. These 3 tools which we are following in our laboratory to do the lot of research, to write a research fund, right? But you should have clear objective in your mind and clear questions in your mind towards your topic, right? Now go to the next one. Second, for the literature review, these are all the tools like Elicit and connected paper and research rabbit. So these 3 papers will give you the clear idea about the literature review. So it will collect all the papers wherever it is available, and it will give you as a summarized content. So through the summarized content, you have to choose whatever you want. So end of the day, each and every moment, each and every AI result, you have to choose the answer, because simply AI, how it is working, it is collecting data from the web itself, right? So by publishing the content itself, it's no need to trust. It may be wrong, right? So we should not trust blindly. That's why we are telling. So this is sample prompt how to this is simple sample prompt to enter into that elicit.org, then you may get a proper question. So through that paper, take a number of citations, which paper having the highest citations, then select that paper. Once if you select that paper, then summarize the paper and alter the paper and collect similar kind of papers. So this is sample prompt, you can use that one. Yes. No. Previous. Yes. See here, that dark dotted line, that is the maximum cited paper. So you should get a proper citations. Then only that paper is authorized one. Otherwise, you don't need to trust the paper, even though if it is a IEEE transactions. So nowadays, many many jumps are happening in the market, research market. So please keep, and also one more recommendation is that now many people are telling that like patent. So patent is again biggest scam in the market. Please be aware of that. So by 5,000, 10,000 rupees, they are providing a second author, third author patent in the sense. Then please don't trust. That will, very near future, DPR is going to amend in our data privacy policy. Someone is having the patent, the same patent someone is transferring or duplicating the patent, that also criminal offense. So by keeping the patent in your name itself will give you the negative black mark. Nowadays, lot of news are running in the market. So please be aware of that patent. Yeah, no. Yeah, draft and outline. See here, use how to use the ChatGPT to make a single draft line. So like our introduction part, methodology part, results part, and then discussion part. So in this format, you should search in the ChatGPT. So sample prompt is that give me an outline for a paper and IMR AD format and put your name. Then it will give you the clear idea. And that also will be like a global data. It's a open data. You have to work on the data. For that data, you have to add real foolproof solutions into your solutions, into your proposals. You have to verify with anyone simulation tools, or else you have to take any real-time results which will be available in the industries that you have to take. Yeah. See here, so for the right section with the AI assistance, so these are all the tools, and take a sample prompt, rewrite the above paragraph to sound more formal and academic. So here the above this paragraph or above paragraph, so in the above content you should give the proper keyword, right? Then only it will give you the results, otherwise it won't give you the results. Go to the next one. And similar way, yes, so take so to generate images or visual graphs, so we are using that tools. We are using Canva as enterprise editions. So with the Canva we are we are creating PPTs also, PPT, videos, charts. And for image, if you somewhere, suppose if you are copying image somewhere, please remove the background and then try to use in your proposal. Suppose if you are reusing the same image into any one of the open platform, please avoid that one. Again here, using the image itself is the copyright issue. Very near future it's going to hit. Yeah. And for edit and refine, so use the Grammarly tools and plagiarism checks, again Turtle-int and then Grammarly. These tools will give you for that plagiarism based solutions. Next. Yeah. See here. Yeah. For reference management, see for developing any one paper, suppose if you are preparing 25 or 30 reference papers, try to put all the papers into your paper. Then only will be authenticated. And also please use the proper version and the proper year and the proper pages of the paper. Don't do any mistake on that one. But now earlier, we did manually, but now many tools are available. Use these two tools, just upload the paper, it will give you a proper way as per the IEEE format. Then you can use it. Just take a snapshot, then you can use it. Yeah. And then, yeah, in the ethical use case, yeah. No. Next. Full, yes. Yeah. See, actually in the ethical way, don't trust AI generated content. That is the first suggestion. Second suggestion, of course, if you took the content, try to add value to the content and try to validate the content. That is the second check. And next one, try to add, suppose if you are, I am working in the e-mobility, so I have a lot of sources in the MATLAB solutions. So what I follow in our proposal, in the sense, if I am saying something in the proposal, I will add a simulation results for the proposal, for the particular problem statement. I will justify for this type of rating, I am getting this results. So from this results, I am trying to improve or decrease 20% higher, 30% higher, or reduce from the baseline. Like that, I will conclude into my proposal. So the suggestion is that try to add simulation results, simulation blocks, whatever it may be. Right? And one more thing is that try to keep one proper mentor, get a mentor advice, and get double time validated the proposed content. Yeah. So these are the popular tools for the researchers. Just to take a snapshot and try to use this one. Of course, always try to use the premium account. In the open account, many false contents are coming nowadays. Yeah, next one. Yeah. So this is the sample prompt for research paper writing for topic and then title ideas. In the ChatGPT, use this prompt to get a broader idea, not a particular idea. Very broader idea you may get it. Similar way for the introduction part. Similar way for the research objective part. Sample prompts. These are the sample prompts, right? We are following. Yes, next one. Yeah, and yeah. So this is for the related or literature review prompt, and then methodology selection prompt, and then results, and then discussion. Of course, you all are using this one, but take a subscribed model and then apply the prompt, then you may get a proper results. Yeah, yeah. So, so the abstract draft and then conclusion prompt. So we are using this similar kind of prompt in our ChatGPT engine. Try to use and try to use single or enterprise account so that your AI agent will get more trained. By using 6 months or 1 year, your AI engine will be more powerful than the other one. Immediately it will not happen, but after 6 months, after 1 year, your engine will get more powerful than the others. For that one, you should have a enterprise edition, that is subscribed model you should have. Yes. Yeah. So I hope you got the complete model of future mobility, like what is the basics, how to enter into the domain, and how to do the research, how to write a content. And if you have any questions, you can ask me. I'm here to help you. Click. See, now the active grant is AICTE RPS grant is happening. Just search, take Google AICTE RPS. Search in the Google, you may get grant scheme name. So this 30th is the last date. How do you see the future of V2G, that is vehicle to grid system evolving, and what are all the key areas needing research and then development? Yeah, see the vehicle to grid, that is that bidirectional converter. So the vehicle to V2G, if you have a proper bidirectional converter, then you may get a super duper research paper. And what research is needed to support integration of EV with public transport or smart city infrastructure? See, this is already it is in the market. So many EVs are available along with the EV charger that is enough. Whereas the public transport, now all the governments taken initiative to convert IC engine to EV, I mean electric EV powered buses. That initiatives already happened. So here your initiative is that battery swapping. If you have a proper solutions for the battery swapping, that also you can involve in this one. What ways an academic research collaborate in this developing practical EV solutions? See here in the industry, different scenarios will be the business case study for the industry. So now we should search what are all the different scenarios which create an opportunity for the job role or research in the particular domain. Like that, you can use the prompt to search the scenarios. Unless if we face the scenario, then we cannot imagine, right? But through the AI tools, we can create some scenarios. So try to identify more scenarios in the EV, then you may get closer connection with the industry. See, in the industry, people are, suppose if somebody is I mean what, somebody is using some solutions. That solution bought by the industry for the particular scenarios only. So now if we have a proper solution for the particular scenario, then we can easily get connected. So try to involve or actively participate in the LinkedIn group. Then you may get a lot of industry connect. For e-mobility, try to focus more about thermal management systems, battery management systems, and then EMI, EMC solutions. Then you can get a better career. Of course, power electronics, if you belongs to electrical engineering, the power electronics will be the better solutions. Yes, any more doubt? Yes, sir. So any more doubt? So if you have any more doubt, please ask me. I'll or else you just take my number. If you have any doubt for your research proposals or any grant access, then I will help you. Right? Thank you. Thanks for your valuable time. Thank you, sir. Thanks for your.
Thank you so much, sir, for the valuable session. Now, to end the session, I would like to welcome Mrs. Vasanta Kumari to propose a vote of thanks.
Good afternoon to everyone present here. It is great honor and privilege to deliver the vote of thanks on behalf of the organizing team for today's session of the National Level Faculty Development Program titled From Content to Manuscript, Mastering the Art of Writing Research Papers, organized by the Department of Electronics and Communication Engineering, Jcet. This FDP is being conducted in hybrid mode, bringing together participants both online and offline. First and foremost, our heartfelt gratitude to our Honorable Chairman, Professor Dr. A. Kanagaraj, our Secretary, Mrs. A. Vijay Kumari, Vice Chairman, Engineer K. Navaraj, and Joint Secretary, Dr. K. Tina, whose leadership, vision, and support for academic excellence continue to inspire and guide us. A special thanks to our Director, Dr. S. Balagan, our Dean Research, Dr. M. Somasundaram, and Principal, Dr. S. Sadish, Dr. Angeline M. Flashy, Head of the Department ECE, Dr. J. Dilip Singh, Head of the Department Mechanical, for their consistent encouragement and commitment towards research and innovation. We are sincerely thankful to our resource person, Mr. Malayappan, Director, Pantech Group of Companies, Chennai, for delivering such an enlightening and a practical session. Our appreciation also extends to all the head of the department, faculty members, non-teaching staff, and our librarian. A special thanks to all our participants, principals, HODs, faculty members, research scholars, and postgraduate students for national and international institutions. We are blessed to share that day 4 of our 5-day faculty development program has been completed. We kindly seek your continued support and active involvement, both online and offline, for the upcoming sessions in the program. Once again, thank you all for being a part of today's event. Thank you.
Thank you all for making this fourth day of FDP a grand success. Thank you all for your cooperation. Let's meet again for the final day tomorrow.